Amplify Science Plate Motion Engineering Internship, Chapter 1, Day 6, Choosing an Optimal Design. Before we jump into the lesson, I want to remind you that all of the materials that you will see here and handouts that you see on the back of the sheet are found in your lesson brief in case you need those at some point, especially since over the next 2 days I'm not in class and you won't always have access to a teacher. When we go to step 1, as usual, takes us out to Future or Workspace. Add to your daily notes with the date and the subject of what tasks you need to accomplish today. Then as a class, hopping over to Reviewing Design Feedback. And this is where I'm going to pull up the projections. You see in the letter, so on day 5, when you submitted your plan, you would receive a letter back. You would have come talk to the internship coordinator, your teacher. They would have sent a letter back to you. And that letter would take a look at the 3 criteria: warning time, false alarms, and cost, and given you either weak, moderate, or good or great feedback. And so here's an example paragraph that might have come from warning time. And it says the average amount of time to evacuate is good. Okay, so good is like you know it. It's good. It could be better, but you might not be able to make it better when you take into account the trade-offs that we're going to look at in the rest of the lesson. So, great is the best, but good is pretty good. And this gives people enough time to get to safety. Now, here's some feedback that you might get on false alarms. So it says your result for false alarms is great. So this group had 0 false alarms. Okay, but it might not be true for all possible tests in Tsunami Alert. In other words, it's amazing that you got 0. That's a really hard number to get. And even though 0 is good, this might be an area that you could consider trading off, maybe going to 1 false alarm to save money or to improve wait times, but maybe not. Maybe you're going to be able to get multiple greats. And here is a 50-year cost example. And here it says, in highlight, it's very expensive, probably not be able to keep the system working. As an engineer, right, that's bad. That's a product that the country either won't purchase or it's going to fail on them eventually because they can't afford it. So here's an area that definitely needs improvements. So in this, most of this lesson is designed to get you to think about those things, look at your feedback and make adjustments. And so you're going to fill in the design feedback summary form. You're going to look at your test results and you're going to fill in the first row. And then you're going to pull out those highlighted areas that we saw in the previous projections. You're going to look for those keywords that tell you whether to keep it the same, tweak it a little bit, or you need to really focus on something in this lesson to really change. Now there's a point, once you've had a chance to do that the whole class needs to share out. You need to have a bigger discussion than just your group, because we can, since we're a large group and have gotten a lot of feedback, we can take a look at weak, moderate, and strong, and maybe even figure out where those boundaries are between those ratings. When does it move us from a weak to a moderate or a moderate to a strong? So what we want to do is discuss each of those things as a class and find out who got what results and what were their numbers to get those results. So we'll take a look at average warning time. Who got weak feedback? Okay, what were your warning time numbers? Is weak feedback 10 minutes? Is it 20 minutes? Is it 30 minutes? Let's see if we can label the highest and lowest ranges we can find so you kind of know where you need to be. And then we'll ask around, say, who got moderate feedback? Well, what were your numbers? And put those either up on the board or in the box. And then who got strong feedback? In other words, things were good and great. What were your warning times? And then we'll do the same thing with false alarms. What's a weak false alarm rating? What numbers lead to moderate? What to strong? Same with cost. Then you're really in position to make good choices. You see, you're not in this alone. We have an entire team. Our whole class can use each other's knowledge to make sure everybody is building systems that work. Now that we have that information, we're going to take a look at trade-offs. When you have to give up one thing in return for another, they come out right at the beginning and tell us the chances of getting 3 great ratings in all 3 areas is going to be really challenging, if not impossible. So you're going to have to decide for you what's the most important priority. You're going to be working towards an optimal design, the most successful considering the situation, right? We're not multi-billionaires. We can't spend whatever we want to get a perfect situation. So we're going to make these trade-offs. Now, your job, once we've gone through this, is to get towards final designs. Okay? So in day 6, after you've filled in these handouts, you're going to go back and modify your design, especially now that you have class results. You really should be able to pick just about which numbers you need to get to know what you're going to get as feedback, even beforehand. And then, of course, in step 2, the final step of the lesson, go back to the Futura workspace, check out your daily notes, make sure you've submitted everything. If you do finish day 6 early, I've released day 7 materials to you and actually day 8 materials to you for this week while I'm gone, and you can move ahead if you need to, but don't rush.